All right, so this lesson is going to be on rationalizing fractions, which rationalizing just means pretty much we're going to be getting rid of radicals in the denominator of fractions. And in general, in order to do that, we need to know some basic radical properties. So for example, in 1a, doing things like square root of 3 times square root of 3, because they're both under a radical, we can multiply them and get square root of 9, which is 3. And then same thing for square root of 7 times square root of 7, square root of 49, which is 7. Same thing, square root of 113 times square root of 113. I actually don't know what that is, but it doesn't matter because you guys can see from before, we're just going to pretty much get rid of the radical and get the number that's underneath. So same thing for square root of a times square root of a. We could write it as square root of a squared, but that's just going to be equal to a. Okay. So we're going to use that property in the examples in number 2. In order to get rid of this radical 3 in the denominator, if we multiply it by itself, we'll end up with a denominator of square root of 9, which is just 3. But if we multiply the bottom by square root of 3, we have to multiply the top, or the numerator, by square root of 3 as well. So we're going to get a 2 square root of 3 on the top, which is already simplified, so we can leave it just like that. The 2 and the 3 have no common factors, so we can't simplify. There's your answer. So you could do the same thing for the next problem. Multiply by square root of 2 on the bottom, square root of 2 on the top. And so we'd get 4 square root of 2 in the numerator. Square root of 2 times square root of 2 is square root of 4. If you take a shortcut, that's just 2. Now this one, unlike the last one, can be simplified. 4 and 2 both have a common factor of 2. So that would make that a 2. Final answer, 2 square root of 2. Okay. So let's look at C. In C, again, you don't really need to worry about the 3 so much. It's the square root of 5 we want to get rid of. So let's multiply by another square root of 5. So that'll give us 5 square root of 5 in the numerator, 3 square root of 25 in the denominator, which is really 3 times 5, which is 15. And now, again, just like we did before, the 5 and the 15 have a common factor of 5, 1 and 3. So final answer, square root of 5 over 3. Okay. One of the properties with radicals that we haven't used yet in this lesson is if they're both under the same radical, I can separate and give each one its own square root. Now in this case, we're kind of lucky because square root of 4 is a perfect square. Square root of 7 is not, obviously, so we're going to have to rationalize this again. So I'll do this one quickly. 2 square root of 7 over 7. Square root of 7 times square root of 7 is square root of 49, which simplifies to 7. And 2 and 7 have no common factors, so that would be your final answer for that one. Okay, so you guys can try number 3. Take a second and try that one. Okay, again with this one, you should be splitting it up. And again, luckily, that square root of 1 is a perfect square. But now you need to rationalize it, which hopefully you're doing. And when you rationalize it, you're going to get square root of 2 in the numerator, 2 in the denominator. This is an under a radical, that's not, so we can't simplify those. Choice 2 is your answer. Okay. We also have some other properties that we can do with radicals, multiplication being one of them. This is just like distributing normally. We're going to distribute the 6 to both of the terms in the second parenthesis. 6 times 6 is 36. 6 times square root of 5 is 6 square root of 5. This one would be a negative 6 square root of 5. And this is a negative times a positive. Square root of 5 times square root of 5, I'll take the shortcut way, is just 5. Now these would cancel. 36 minus 5 is 31. Okay. B is almost exactly the same. I'll give you the answer. Negative 3. Pretty simple. You'd get a 4. The outer and the inner would cancel. And then the last term would be minus 7, which would give you negative 3. C is a little bit trickier because when you distribute, square root of 10 times square root of 10 is a 10. Again, the outer and the inner are going to cancel because one will be positive, one will be negative. Minus square root of 2 times square root of 2, which is 2, will give you 8. Okay. All of these are something special called conjugate pairs. And these conjugate pairs happen when you have the same two binomials, but one's a plus, one's a minus. One's a plus, one's a minus. So within these conjugate pairs, you'll always have that happen where the outer and the inner terms cancel out when you distribute. Okay? Let's go on to the next page, which